that is nothing but 55031
Please be on mute.
dot 00.
Yeah, so this is the problem. So here first we will understand how to construct a FP tree. Okay, so this is the FP tree algorithm. We need to understand how we do the frequent pattern mining using FP tree algorithm. But before that, we need to understand how to construct a FP tree. So try to understand, this is the transaction given to us. So these are nothing but the different item sets transactions. Like in transaction 1, you have these, transaction 2, you have these items, and minimum support is true. So first, let's understand how to draw a FP tree. First, what you have to do, you have to take a distinct count of all the items, like all the what are the different items we have here, A, B, C, D, E. So we will take the distinct count, like A, how many we have, 1, 2, and 3. So B, how many we have, 1, 2, and 3. So how many times those items have occurred in all the transaction, that we will write here. So that is nothing but the support of that particular item. And then we will remove all the items, we will eliminate all the items whose support is less than the minimum given support, that is 2. So in our case, EFG has a minimum support of, has a support of 1. So we can eliminate these 3 items. Now, whatever we are left with, we should write in step 2 in a descending order of their support. Okay. So 4 and then after 3, 2, 1. So here we have 3 for everything. So you write like this, A, B, C. Once this step is done, now your final table is this. Now using this item support table, you redefine your original given table. So we have to redefine your given set. Redefine in the sense, so earlier the order of the items given here was BDCA, but you have to arrange these items in this order. Okay, in this order of the support. That means your first should come D and then A and then B and then C. So here, if you see, this order is different. So you have to redefine. So step 4 is nothing but redefining your original table. So you will be writing it as D, A, B, C in the decreasing order of the support. Similarly, transaction 2, you have E, D, C here, but you forget about E because we have already eliminated E. Okay. So here we are eliminating in the beginning only. Okay. And then we are left with D and C. So we'll write in the decreasing order of their support. So first D has a highest support. So we are writing D. So if you see in every transaction, your D will be first because it has the highest support. So we are redefining this table. So similarly, if you see transaction number 5, FG, FG we have already eliminated. So we will not take that. We'll take only D and B. Next, this step 4 is done. Now comes how to draw your FP tree. Okay. So you will start with transaction 1 for T1. For T1, we will start. So first you will take a root element. Okay. This will be your null. You will not have anything. So you will connect all your items to this root. Now first is D, A, B, C. So you will connect all your items in a order. You will connect your D to the root and then A, B, C, and support is 1 for all because you have 1, 1, 1, 1 times. Now first transaction is done. Next is transaction number 2. For transaction number 2, the items are D and C. If you see, D is already connected to the root. Okay. So you need to just connect C with the D, and you should increase the support of D by 1. That means already here D has 1 support. You have in transaction 2 you have come across again D and you are connecting your C with the D. So support of D will be increased by 1. Now for transaction 3 we have A and B. If you see, A should be connected to root here now because your first element is A here. So you cannot put your B here. Okay, your A should be connected, your first element should be connected to the root. So what we will do, we'll take another branch and we will write here A and then connect a B to that. So now the support will be 1 for A and B here. Coming to transaction number 4, we have D, A and C. Okay, so D is already connected to root. Then you have A is also connected to the D element, but you have to connect with A, C. So in your transaction 4, you have D, A and C. And you should remember, you should keep on increasing the support. because you are connecting this C with your A and D, right? D, A, C. So you increase the support of D by 1 and A also by 1. Next, last transaction, transaction number 5, which is DB. So D is already connected to root, but you have to connect B to D and increase the support of D. So if you see, this will be your final FP tree. And what we have done for the transaction number 5, we have connected B to D, and here you have your support of B is 1, but you have to increase the support of D to by 1. So if you see finally,
Anu, you are on mute. Mute, I think. Please unmute and talk.
since when I am on mute? Since beginning?
Just now.
No,
No,
last
no, just now.
Okay.
60 seconds. 60 seconds.
Yeah. Okay, then I just told that final in your FP tree, whatever support counts you have got, that should be equal to the support count that we have received in this table. Okay. So if you see for D, we have got final support count 4. So you should tally your support count finally. Okay, so that you don't miss anything, because while we are constructing this FP tree, we may forget to increase the support of any item. Okay, so that you can tally it fine. So this is how we construct the FP tree. Now we'll see from the FP tree, how do you mine the frequent patterns? Okay. So I have taken, this was very simple. So this is some little complicated FP tree I have taken. So from this FP tree, how to construct, how to find the frequent item set, and what is that method called? That method is called using conditional pattern base. Okay. Now, first, what we have to do, first you write your elements. What are all the elements and what is their count from this FP tree? So what are all the elements? Start from the leaf nodes. So we have in the leaf node I5, and then we have I4, then we have I3, and then we have, then we can take internal, whatever it is. So first start with I5. Can you please unmute mute yourself? Yeah, I5. I5, how many elements we have? What is the support count of I5? If you see where all we have I5 here, we have here, we have here. So support count will be 2. 1, 2. So 2. And then start with I4. 1. And where else we have I4? Here, here. So 2. Then we I3. 2, 2, 4 plus 2, 6. Next I1. I1, 4 plus 2, 6. Now we'll discuss why we have not taken I2. See, we have not taken I2 because I2 is directly connected to root. So you should not consider item which is directly connected to root. But then I1 is also directly connected. Then why we have taken I1? Because I1 is present below also, below your parent node also. Okay. So if an element is existing along with the root node, I mean, if it is connected to root node and also present somewhere here in the below, it's then you should consider. But if any element which is connected only to root but not present anywhere else, then that you should not consider. Okay, so that's why we have eliminated I2. So now we have got these items. Now we will start finding out the frequent item sets. So how to start the frequent item sets, how to make it, so first start with I5. Okay, let's start with I5. Now if you see I5 in your FP tree, what are all the branches that I5 is connected with? So if you take, this is one branch, right? So what is there in this branch? I3, I1, I2. What else branch we have I5 connected with? This one. I1, I2. So I1, I2 and I2, I1, I3. So we will write in a pattern what are all the branches that we have got, I2, I1, and you have to write support 1. How this 1 came? If you see I5 support in this branch is 1, in this branch also it is 1. So for both the branches we have written support as 1. And then which is the elements which is common here. So I2, I1 and I2, I1 is common, and support will get added, because one support from here, one support from here. So 1 plus 1, 2. Finally, to get your frequent patterns, what you will do, you will join your I5 here with I2, I1. Okay. So this is one of your frequent pattern that you have obtained. So if you compare with a priori, if we have to do with a priori, you will have to do all candidate generation with different support counts and all, right? But here, if you see in this case from FP tree, we have obtained just with 2 steps. And if you see here, we have what we have done, we have taken all the branches where I5 is connected to, and then we have found out the frequent pattern in these two sets, and then we have joined I5 with that frequent pattern set, and we have also written the corresponding support. Similarly for I4, then if we go for I4, now let's go for I4. So you have I4 here, you have here. Now, if you see what are all the branches, I4 is connected to this I2, and then I4 is connected with this branch, I2, I1. That means one is I2 and another one is I2, I1. So I2 and I2, I1, and I4 support is how much here? 1. So we'll write 1. Now, what is the common between these two? I2 is common. So that's why our frequent pattern will be I2. And then you join, complete your pattern set, you join I4 with I2. So this is one more pattern that we have got as a frequent pattern, and the support count is 2. Now I3 is little different. So try to understand about I3. Where all we have I3? We have here, we have here, and we have here. Now let's see one by one each branch. This one is I2, I1. Okay. So I've written I2, I1, and support count of I3. Support count of I3 is 2 here in this branch. So that's why you have to write 2 here. I2, I1, 2. And then coming here, another I3. So here it is connected to only I2. So set is I2 and support count is 2. Now coming to another I3, here it is connected to I1 and support count is 2. So hence here you will get I1, 2. Now here you have to understand carefully what I'm going to do. You have to find common. Okay. But you have to take common from these two, and this will be separate, because so this is going to be separate, because if you see here, this is a separate branch altogether. Other I3 values, other I3 pattern that is coming, that is in the same branch on this side only. Okay, that from root it is you have only one connection. Okay, for both the branches, but this particular branch is totally isolated. So that's why you don't consider while finding out common, between these three. You'll take these two together and this separate. So between these two, what is common? I2. So that's why we've taken I2, and support count will get added. 2 plus 2, 4, and I1 is 2. Now what you have to do, you have to join I3, I2, I1, and you have to write it together, and support count will remain 2 only, because here it is 4, it is 2, whichever is value less that you have to take. But here I have missed one step. Okay, what you need to do, you need to write the subsets of this also. If you see I1, I2, I3, so you can write for every step, you can write the subset. So what I'm trying to say, like if you take first one, the frequent pattern that we got is I2, I1, I5. So this is one pattern. Now all its subsets also will be frequent, right? So you can write all these, in the exam, you can also show all the subsets in your answer. I2, I1, or I1, I5. Okay. All these also will be your frequent pattern. So all the subsets you should write. Then I2, I5. Okay. All that subsets also you should write for all of this. And now coming to last I1, it is connected to I2. Then support count for I1 is 4. If you see this one, I2, it is connected to I2. Hence, you will have one more frequent pattern, I2, I1, 4. I hope this is clear. Before moving to next topic, if anybody has any questions, please, one by one, but I'll wait for 5 seconds. If no question, I'll proceed. Okay, so
So
then I
if
assume, yeah,
hi, Anu.
yeah.
So for this, we won't find confidence and confidence percent for this after finding the frequent patterns also.
No, no, no. If they've asked, then we will do. But they have not asked anything here. Here, just we are trying to find what are the frequent patterns that is coming from based on this FP tree. So basically, in the exam, there will be some table given like this, and they will ask you to find the frequent pattern using FP tree. Then what you have to do, you have to do all these steps, and then first draw your FP tree. After your FP tree is completed, you need to do this step and then find out the frequent patterns.
Okay,
Uh,
if asked, we can compute that, right?
Yes.
Sure, sir. Thank you. Thank you.
Yeah.
Anu, I have a question.
Uh,
So
yeah.
in the FP tree, right? So
Yeah.
I2 has the highest support, like in the question 2, right? So why was that left out?
We have not left it out, right? It is coming, right? I2. If you see in your frequent patterns, you have I2 everywhere. You have here, you have here, you have here, you have every. It is only from this FP tree how we are going to mine the frequent patterns. We have that is one what I say that in algorithm that is one of the step, that is one of the point, that whichever element is directly connected to root, you're not supposed to consider that in item
Okay.
while writing the count of item.
Okay, but there is no
I
specific logic as such, like
there should be a lot. I mean, there is a logic. I think we need to analyze it. But if you see, you have I2 everywhere.
mm,
Everywhere you have. And then if you uh, uh, see the frequent patterns, so every pattern is coming with I2 only.
mm.
So
Okay,
I don't.
so this is the case when you want to get the frequent patterns given an FP tree.
Yes.
Okay.
Yes. Yeah.
Yeah, I have a question
Yeah.
for the table, right?
Yeah.
If you go to I3, so you have written separately I2,
Yeah.
I1 slash
Yeah.
2 and then I1 2 with a different branch. I missed it. Can you explain again?
Yeah, so here why see everywhere what we are doing, we are trying to find the common items and then we are writing here. But in this case, right, you should not take these, I mean you should take these two separate and this one as separate set, because this I1 2 is from different branch. So from the root you have two branches at the top level, and for that I3, this I1 is coming in separate branch altogether. This is nowhere having any connection with this one. That's why.
Okay, okay.
Yeah.
Yeah, thank you.
So finally, you don't see what are all the items we have considered. That is different thing, okay? Just try to see what are the patterns that we have obtained finally. Okay.
So, but then
Okay.
it
So,
will be more than the one that you have specified, right? It will have the subsets of
Yes,
the
yes, you should write the subsets also. Yes. You for each one of these, write the subsets.
Anu, one question.
Yeah.
The subsets will have, let's say, the last pattern which is there, right? I1 and
Yeah.
I2.
Yeah.
The I3 will also have a subset of I1 and I2. The
Hmm.
frequency of that will be the combination, like it will be 6 for I1, I2 in that case,
No, 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 no.
or
No, no, no,
oh,
no. So for this separately, for this particular set, the item, I mean, what will be your subsets? I1, I2, 2. I2, I3, 2. Or I1, I3, support count 2. Something like this.
okay,
Yeah.
all right, okay, thank you.
Okay, next, let's move on. So this is the question that has, this is from previous exam paper, and this is based on the total first two concepts that we have seen. So this is a problem given in exam. This is how the problem will be given. Here they have given us minimum support and minimum confidence percentage. We will see when we will make use of this, and they have given you some transactions, okay, and they've asked you to find a frequent item set using FP tree. So this is what it will be given. Now all the above two problems, what are all these steps, that all we will have to do in this problem. But first of all, convert your percentages into normal number. So how do you do that? 60% of this 5. Okay, 60% of 5 will be 3, and then 80% of these 5 will be a 0.4. Okay, now find out count of each item. First, you find count of each item. That was our first step, right, from first problem. So all your distinct items, bread, butter, beans, potato, shampoo, for all your distinct items you can write, and then write down the count, and write down which all transactions they are appearing. So okay,
Anu,
like yeah,
5.4, 80% 0.4, it should be 4, right?
80.
Percent you have shown as 0.4. Why?
It should be 1 minute. Let me 80% of 5 items, right? 1,
Yeah.
2, 3, 4, 5.
If 60% is 3, 80% is 4, right?
4, 4, yeah. Yes, maybe some mistake there.
Okay.
Yeah, so first we have to write all the counts here of all the items, and then we have to write in which all transactions it is appearing. Okay, like if you see butter, it's coming in transaction 1, transaction 2, transaction 3, transaction 4, transaction 5. So that numbers I have written here. Okay. Next, what you have to do, you have to check for whichever item support is greater than 3. Okay, those only you need to keep, rest all you can eliminate. Okay, so only all these items will be available to mine your frequent patterns, rest all we have eliminated. Okay. Next step is write down all your items in the decreasing order of the count, all the items that we are going to consider. Next, same step, you need to redefine your original table. So original table is given like this. So you redefine based on the support count. Like first butter should come, then bread, then milk, then jam, then beans based on this decreasing order. We have just ordered this item set. Okay. Next, you start constructing your FP tree. As I said, FP tree, start transaction by transaction. For first transaction, it will be all connected to root in order. Then for transaction 2, bread, butter, milk, jam, that is already coming in the same order only. So for transaction 2, nothing, no other branch will come, but support count should be increased by 1 for each of these items. So if you see here, 2, 2, 2, 2. Now for T3, bread, butter, bread, beans. So butter is already connected to root, butter, bread, and beans. So you just connect beans here and then increase the support count. For transaction 4, butter, milk, beans. Butter is already connected to root, but here you don't have but directly milk connected. So take another branch, milk, connect beans, and then increase the support count of butter. Next, you have last butter, bread, and jam. So butter is already connected to butter, bread is connected. Then from bread, take another branch and connect jam. And you also have to increase the support count of butter and bread. And finally, you can verify your support counts with your table. Next step is after FP tree is done, next step you have to mine your frequent patterns. Okay. Now, which are all the items that we are going to consider? We will consider beans, we'll consider jam, we'll consider milk, we'll consider bread, but we will not consider butter because that is directly connected to root and we don't have anywhere butter coming below. Okay. So we will not consider butter. So ignore butter as it is directly connected to root. Next, take item milk. So now what are the different patterns with milk that we are forming? We will see that. So if you see here, milk is connected to bread and butter. Milk is connected to only butter. So first bread, butter, support count of milk is 2 here. So 2. And here it is connected to butter, support count is 1. So 1. Now common is between these two, the common value is butter. So support count will get added 2 plus 1, 3. And then finally in your answer, you join milk, butter and support count will be 3. So this is one frequent pattern. Okay. Now similarly for jam also, I am not going to again show the FP tree. Just for jam also in the same manner you should do. And then find the common. Common is bread and butter here. So we have written bread, butter, added the support count and then joined a jam with this one. Here I have shown you have to write the subsets also. So bread, butter, jam is one total frequent item set, and then its subsets will be bread jam, butter jam. Okay, and support count you should mention 3, 3. So this is how in the exam you should write.
Anu?
Yeah.
In the first row, in frequent pattern, buttermilk is equal to 3. How come?
Because if you see here, as I told in the first problem also, when you are joining these two, when you're finding out the common, you need to add up this support count.
Then in the next one, when we are joining milk, bread, butter, so why
Yeah.
it is 5?
It's not 5, it's 3. Is it looking 5?
This is 3.
Yeah. 2 plus 1, 3.
Okay.
Is it clear?
No, why are not we considering bread and butter in frequent patterns?
Where we are not considering?
Here only, yeah. In frequent patterns, we are considering butter jam, bread and jam, butter, bread and jam, and there should be another frequent items of bread and butter, right?
Yeah, you can write down. I just wrote some, just
Oh.
whatever I remember. I mean, I saw. Just to show that you have to write subsets also. You can write butter bread also.
Okay.
But I think maybe jam should appear. This is for jam, right? With jam, what are all the frequent patterns? I think.
See if in frequent, I mean in the pattern base, whichever sets we have, that should not appear in the frequent pattern. It should appear with the item added up, so that we
Yes,
get
yes.
the frequent pattern, right?
Yes, yes. So
So
jam
that
should
doesn't
appear.
make any sequence here.
Yeah. So jam should be appearing there. So coming to beans also, it's the same again. I have written all the sets and then which is common here, butter is common. So support count is 3. So you need to join beans with butter and then you will get 3 total. So I think this is clear, okay? Second bit for this question is find the most interesting association rule involving 3 items. Now, out of all these frequent item set, which rule is most interesting rule? They want to, we need to find, and it should involve 3 items. Now, out of all these, which is the one which involves 3 items? So, bread, butter, jam is the one where we have 3 items, okay? So, if you see, so from this bread, butter, jam, what are the different possible rules that you can form? So you can form like bread butter implies jam, bread jam implies butter, okay? And then jam implies butter bread. So all the rules that you can form in the form of X implies Y, that you should write. And then you should find the confidence value of that particular rule. So if you see bread, butter, jam, its confidence is coming 75%. How? Let's see, bread, butter, jam. So what is the confidence formula? The transactions where both x and y is present divided by transaction where only x is present. Now in this case our x is bread butter and xy is bread butter jam. So how many transaction, what is the support count of the transaction where you have all the 3? Support count is 3. So 3 divided by, now what is the support count where you have only x in the sense where you have only bread butter? So if you see bread butter, here support count is 4. So 3 divided by 4, 200, so you will get 75%. Okay. Similarly, you find for all your rules, okay, that you have written the confidence value, and they have given us that minimum confidence they specified is 80%. So you need to consider all those rules where your confidence is more than 80%, and then you need to mark them as most interesting association rules. Any doubt in this one?
Anu, can you just calculate the confidence for jam, butter, bread? Jam implies butter, bread.
This one?
I just want to calculate that once.
Yeah. So if you go here, first where all the 3 items are occurring, jam, butter, bread, it is 3. It was 3, right?
Yes.
3 divided by where only jam is coming. So for jam, what was the support count? 3.
Got it. Okay, understood.
There I've written, yeah, 3. So 3 by 3 will be 1, so 100%.
Got that.
Okay. Okay, then
Hey, Anu,
yeah.
Anu, in the beginning, like we get the count of each individual items. So in that, if the support count is same for 3 items like milk, jam, and bean, for all these 3, it's same. Which will come first and which will be the next one? Do you have any idea
That
on
was
that?
a question, okay. But in case of alphabets, if it is given, you write in alphabetical order. But I heard that in some section, ma'am has taught that even if like this it is given, write that also in alphabetical order of decreasing order.
Oh, decreasing order of alphabet. Okay.
But I don't know how it is going to make difference. It should not make any difference, but that's how it's being taught, it seems.
The FP tree will be different if the arrangement changes.
No, but it should not make any difference, right? We should be able to write anything. That's what I think, but I don't know. People
FP3
are
will
saying
change.
FP3 will change.
It won't make any difference in the frequent pattern calculation.
Exactly. Yeah. But
Okay.
to be on safe side, let's write in alphabetical order only. Okay?
Yeah. Okay. Thank you.
No, one quick question.
Yeah.
So after we construct the FP tree, and then when you are creating the the frequency items, you said earlier that we need to start from the leaf node. Is it mandatory, or we can start from any node?
No, we can start from any node. Just to not to miss out anything, I am starting from leaf node. I didn't start anything. I didn't start here from the leaf node. If you see, I took milk. Okay, I took milk and then some. But it is always better, right? We will not miss out anything. Like you can do first for beans and then you go in that order. It doesn't make any difference.
Yeah, the difference. Okay.
Yeah.
Anu,
Okay.
how did we arrive at that 80% when we are, that 80%, was it
That
given
is
in the
given. That is given in the question.
Okay.
Okay, let's move on to the next. Please, everybody,
No,
please mute. Yeah.
Can you go to the previous pages?
Yeah.
One more. Yes. Wait. Here, the support count for I3 is 2 for the leaf node. It should be 1. Or no. In the other leaf nodes, I3 support count is 2.
Yeah.
Should it be 1 for leaf nodes?
No, why it will be 1? You have to take it like this only. From here only you have to take, right? So, no, this is the FP tree given to us. I have not derived from anywhere.
Okay.
Yeah.
Anu, I have a question. I mean that can last. You just wanted to check on the rule generation, right? If you see the item, so just take an example for I5. So you showed right how the rule generation will be taken.
Yeah.
So similarly, we have to go for I4, I3 as well as I1.
Yeah.
Okay. So considering the timeline, I think will the examiner give for rule generation for all? Or I mean,
So I'm not sure what examiner will give, but this is how we need to do. Okay.
Okay. Yeah.
Yeah. So I will not take any more questions now. Let's move on. So this is next topic, rule interestingness measure. So rule interestingness measure is nothing but now whatever we were doing here, we were trying to find out which rules are interesting rules here, right? So we used the method of confidence. So we can use support, confidence, but this support confidence has some drawbacks. Sometimes they are misleading. Okay, they are not giving us correct results. Okay, sometimes it happens for some data. So in that case, we can use lift. So lift is one concept where you can find out if your rule X implies Y is an interesting rule or not. Okay. Now formula for lift is P A union B by P of A. So this is the probability of A and B and probability of A and probability of B. And if your lift value is less than 1, then A, you say that A is negatively correlated to B. And lift value is greater than B, then A is positively correlated. Lift value is 1, that means A and B are independent. Okay, there is no relation.
I know one question.
Yeah.
This lift, is it the ratio of the above two things like support?
It is something like that only. This is the formula, that one more formula I have written. Transaction containing both x and y. Transaction containing x divided by.
Right? That is confidence, right? The
That is
numerator.
confidence, yeah. And fraction, yeah, it is confidence by support.
That's what I was asking. Confidence by support is lift.
Yes.
So Anu, this is lift is greater than 1, right? Then it is A is
positively correlated. Yeah.
Okay,
That means
lift
there
is
is
greater than 1.
Greater than 1, sorry.
Yeah.
Okay. There is a mistake in writing. Yeah. So next we will see the example for this one. So this contingency table is given. In this contingency table, we have written something like, so this is the count where you are going to, you are buying both video game and computer game. And here, so this contingency table is written based on the probabilities. So this is given, okay. From here, you have to find out what is the lift. So based on this formula, we will find out now from this table probability of purchasing computer game, only computer game. So what is the value for only computer game? This one. So probability will be 0.60. Okay, 6,000 by total value. So that's how I have calculated. Then probability of video game. Okay, video game is here. 7,500 by this. So this probability of game and video. So game or video. So this is 4,000. So 0.40. So we have filled it in the formula and then we have received the value 0.89, which is less than 1. Hence, video game and computer game are not correlated to each other.
How did you reach that conclusion? What is the correlation? From the correlation, did you reach that conclusion or?
No. This value, right? Lift value we have got 0.89, which is less than 1.
Which means 0.89. So you consider as not correlated or?
Not correlated, negatively correlated.
Yeah. How big? See, is it a binary thing? 1 or not 1? So usually 0.9 is considered as high correlation, right?
No. Here, as per lift, if it is less than 1, A is negatively correlated. If it is equal to 1, they both are independent.
Okay. And it can't be more than 1, right? It can't be, right?
It can be, right? If it is coming more than 1, then it is positively correlated.
Oh, okay. Oh, so it's not the typical correlation value which ranges between 0 and 1. It is something.
No. It is just a normal value.
Oh, okay, understood.
Yeah. So this was about, yeah.
How is probability of purchasing both 0.4?
Because here, if you see game and video game, the value is 4,000.
4,000 by 10,000.
10,000, yeah.
Yes.
Total we have 10,000, right? Total value. Okay, next we will move on to clustering. This is the next chapter. So clustering is, I think everybody knows that it is nothing but how you divide your transactions into different clusters. Now this is K-means clustering method. So I will directly go to clustering method. I'm not going to explain this algorithm because without problem it is difficult to explain. Once after seeing the problem, if you read this, then it will be clear. So here for K means, now this will be given like this, the transaction set will be given, and then they will ask you to divide this into K means cluster. That means they can give you 2 means, 3 means, 4 means, that means number of clusters. So here, let's say we are taking 2 clusters, K1 and K2. Sometimes they will give you the centroid of these clusters. Sometimes they will not give. So if they have not given the centroid, so what I have done, I have taken 2 rows randomly. First 2 rows at the centroid of K1 and K2. Then you need to find Euclidean distance from row 3 to K1, row 3 to K2. Here, if you see, you have found the distance from row 3 to K1 and row 3 to K2. And after finding out the distance, Euclidean distance, whichever distance is less, okay, that value will go to that particular cluster. So here K2 value is less. So K2 will go, this row 3 will go to cluster K2. So that's why K2, in K2 cluster, we have got now 2 and 3. 2 was already there. 2 we already took in under cluster K2, and 1 we have taken under cluster K1. Now, once we found for row 3, the distance between your row 3 and K2, row 3 and K1, you saw that distance for between K2 and row 3 is less. So you need to move your row 3 into cluster K2. And finally, these are the clusters formed. Next, again, same activity you need to do for row 4. But before doing that, your centroid will shift. So as you have moved your row 3 to K2, so wherever you have moved your, whichever cluster your row has gone, you have to recalculate the centroid for that particular cluster. So for K2, you need to recalculate the centroid. So how do you recalculate is whatever is the original centroid plus this divided by 2. That means 170 plus 168 by 2, 56 plus 60 by 2. So then I recalculated the centroid, and then your K1 remains same and K2 centroid is changed. Now same procedure do for row 4. That means find out the distance of row 4 from K1, row 4 from K2, and then whichever is less, that particular value will go to that cluster K1, not value, that particular row. So that means now row 4 will go to cluster K1, hence cluster formed will be 1, 4, 2, 3. Now your row 4 has gone to cluster K1. So what you need to do, you need to recalculate your new centroid for K1. So for K1, how will you recalculate is whatever K1 value, original value 185, whatever K1 value you have taken here, 185.72 plus whichever row has gone to that cluster, take that row and find out the new centroid. Once you have found out the new centroid, again write down what is your new centroids for K1, K2, and same procedure you repeat for row 4, row 5, row 6, and finally you will see that in your cluster K1 all these values will come, and in cluster K2 all these values have come.
Anu, one quick question.
Yeah.
Why we have taken K as 2 and not 3? Like, was it in the question or how is it?
Nothing is given in the question. Generally, it will be given. This is just a normal. I have told you example. They can give you 2 K value as 2 also or 3 also. If they have given 3, then you have to take 3 clusters, K1, K2, K3. I just took 2 clusters to show you the total procedure.
Got it. Got it. Thank you.
Okay. Yeah. So let's move on. Now, this is the problem. This is from previous exam question. So this is how the question is given. So all the points are given P1, P2, P3, P4 like we have seen above. And then they have told that use 2 means method.
Sorry, Anu, one question, okay? So in the previous example, so as you added new points, you have recomputed the centroid.
Yeah.
But as per my understanding from the class, so it's like, so once we have some centroid, so initially we have consumed that K1, K2 as centroids, right? We need to compute for all the points, what is the closest neighbor? And then, so after we computed all the points, then again we have to recompute it. It's not like for every point we will be recomputing the cluster. That was my understanding from the class. So
Yeah, we can do
Yeah,
way.
I heard that in
We can
class.
do either way.
Yeah, in some section they have taught like this. For our section, they have not done any numericals itself. So this I have taken it from, from YouTube or somewhere. So, but I see that final answer is coming perfect.
Okay, so as you add each point, you recompute the cluster. And when do you stop? When you arrived at the last point? Because in the previous example, when I said I stop when the centroids doesn't change.
Exactly, that is the centroids will converge. But here, what we are doing, we're trying to find the clusters, right? I stopping till last row. I'm doing.
Okay.
I think that's right. If you look at a lot of YouTube videos, they ask you to recalculate after every stage, which reduces the number of iterations. But in section 1, what sir has told is that do one pass, do another pass, which is probably much more laborious process.
Yes, yeah, I get that. But Okay, if both converges to same answer, it is good. Yeah.
Okay, let's move on. This is the next this one problem. Here you see that we have given with all the points, and then here in this problem they have told find using two means method. You have to cluster these data points, and here they have given us the centroid C1 and C2 value they have given. That means you have to do two clusters, and they have given the centroid. Now for each row you need to find the distance P1 C1 P2 C2. So I found the Euclidean distance, then whichever is less, cluster will go, I mean row will go to that cluster. So in this case, P1 will go to C2. And then for C2, we are recalculating the centroid, original centroid plus this divided by 2. So I think this is very, just you have to remember the steps. It's very simple. So you form these clusters finally. Then similarly, you have to do for iteration, next iteration. Just give me 1 minute.
I think there is one more point, right? So the distance formula itself can change, right? They can ask for, instead of Euclidean,
Yes.
they can say use Manhattan, right?
Yes, they can say that. That if they don't give anything, you can use Euclidean. If they have given, then you have to use that only.
Yeah.
Yeah. So similarly, we can do for all these rows till P6, and then finally you keep on adding, and then you will get your clusters. C1 is this, C2 is this, and if you go back in your C2, you have only P1, and in C1 rest all. If you see the data also, you will be able to. So if you see your one cluster has only 0.4 and rest all your clusters have this points. So if you see, if you plot also, right, this point will look far from all these points. Okay.
We have 0.45 here, right?
0.4 only.
At the end, P6.
Yeah, this is 0.45.
So compared to P, let's suppose we take P5 and P6, 0.08 and 0.45 are more distant, and here 0.4 and 0.45 less distant, right?
This is 0.08 only.
Yeah, no, you place these points on XY coordinate and then see.
Yeah. Yeah, I mean, this is the clusters we have formed. So it's not like, see, every cluster may have that also, right? Some drift. It's not like that, so in your large data, you may get some points. So that's why we have further different, so this is using k-means, right? So because we have some problems in k-means, we have other methods like db scan and optics and BIRCH, right? So where we have more refined clusters.
And also k-mean is not very good in finding outliers. That's one of the biggest disadvantages.
Exactly.
That because it continues to create centroids. So your ability to find outliers is very weak in k-means. So
Exactly.
you
Yeah.
will face that problem in k-means.
Yes. So we are able to find cluster. We are able to see the cluster, but maybe there may be some outlier present here. That we will see that how other methods are helping us to do that. Okay. So let's move on to
Hey,
hierarchy.
Anu,
Yeah.
Anu, sorry, one question. So when we are calculating the mean after adding one extra point each time, so do we like sum and then divide by 2 each time, or it increases with the number of points in each cluster?
No. Every time divide by 2. Only 2. It's average, right? You're calculating mean, so you are taking the 2 values only, right? Every time.
Okay, got it. Thank you.
Okay, next is hierarchical clustering. So in hierarchical, we have agglomerative and divisive. Okay, so agglomerative is nothing but bottom up approach. So like from bottom, you will go in top. Okay, so one cluster is formed here, one cluster is formed here, then one cluster here, then total cluster here. But in this is called as dendrogram, and then you have a divisive where you have top down approach. In top down, you will come from top, and then you will keep on splitting into your clusters. Okay, here you are forming a clusters, here you are splitting up into clusters. So we will see one by one. So in agglomerative, you have single link technique and complete linkage technique. Okay, first we will see single link technique. So first you have to draw your distance matrix. Okay, so like some points will be given like P1, P2, P3, P4 like that. For based from that table, first you need to draw your distance matrix. You need to find out the distance between your P1 and P2, P2 and P3. So these diagonal elements will be 0 because from itself it will be 0 only. And you need not write this upper values, just write this lower triangular values and then write the distance matrix. And then here we need to do the clustering. Now first see in this particular distance matrix which value is the lowest value. So least value is 2, right? So what is this distance between? This is between P3 and P5. So you can cluster this P3 and P5. So P3 and P5 can be clustered and the distance is 2. So now again you rewrite your distance matrix and here you need to write P3, P5 together and here also P3, P5 together. But now inside the matrix the values between P1, P1 distance 0, between P1, P2 it will be 9. From above table you can write, but between P1 and P3, P5 you need to find out the distance. Okay, and how do you find? You need to, as they have told, single linkage technique. Single linkage technique means you need to take minimum distance between P1 and P3 and P1 and P5. So distance between P1 and P3 and distance between P1 and P5, whichever is the minimum, that value you need to consider your distance between P1 and P3, P5. So value will be 3. Similarly, find out the distance between P2 and P3, P5. Okay, and then P4 and P3, P5. Okay, so in the same manner, I'm taking minimum distance for each of this, and then I have written down these values 3, 7, 8. Now again, from this table, from this matrix, which value is minimum? 3 is minimum here. So then you can cluster 1, P1, P3, P5. That means one more cluster P1, P3, P5. So here the value is 3. That's what I've written. So again, you need to draw your matrix. And in matrix, now you combine P1, P3, P5, P1, P3, P5, rest all you write like this. And then you have to find the distance between P2, P1, P3, P5, P4, P1, P3, P5. So these two distances you need to find using single linkage technique, which is nothing but the minimum distance between your P2, P1, P2, P3, P2, P5. So write down like that. In if you write it stepwise, it will be more clear. So find out the minimum distance. And then here also find out the minimum distance, put it in the table. Now again see which element is minimum here. Minimum is 5. That means you can form one more cluster P2, P4. And then you can P2, P4. One cluster more here. And here also again you draw your matrix table. And then you have to find a distance between P1, P3, P5 and P2, P4. So each one, whatever all combination is coming, P1, P2, P1, P4, P3, P2, P3, P4, P5, P2, P5, P4, all combinations distance you write and then write their distances, whichever is minimum value, put it there. So final, this is one. Final, your complete cluster is P2, P4, P1, P3, P5. So this will be your final top level cluster and the distance is 6. This 6. So this is how single linkage technique clustering is. Now coming to in this, yeah.
When you calculate original distance, we need to use Manhattan or Luciden?
I have used Euclidean distance, but if they have given Manhattan, you have to take Manhattan.
Okay.
Basically, they have given already this distance matrix, okay? And here, when we are trying to calculate, we are just taking the minimum value. We're not doing anything.
Okay, if we have multiple the minimum value, then what value we have to consider? I mean, which the item or the thing we have to consider?
You mean same minimum value?
Yeah.
You need to take that's minimum whatever same means. If suppose you have 7, 7, 10, you will consider 7 only, right? Minimum value.
No. I mean, while starting the problem, so can you go back to the one the input the matrix?
Achha.
So here,
okay,
so here if you have
I think you can consider both. This question, I also have in my mind, but I didn't find anywhere any such problem. But if you go by logic, I think we should take both and do the clustering both together in that iteration only.
Okay, so in that case, that tree structure will be, I mean, in a single kind of branch, we will have all the element.
So if you take, let's say that here also, if we have 2, and for P2, P4, yeah, these all will come under 1 then.
1, right? Okay.
Yeah. I mean, we should try out that problem by taking some similar distance matrix, but I didn't find any numerical on that.
Okay, thank you.
Yeah. Next is the max complete linkage technique. So in max complete linkage technique, every whole process is same. Only thing is, you have to, instead of minimum, you have to take max distance. You have to consider maximum.
Just one question. This table will be mentioned in the question, or we need to derive it from somewhere?
If it is not mentioned, they will simply they will give you the points, like P1 is 2,3, let's say, like this they will give. You have to write down the distance matrix, like they will give P1, P2, P3, then you have to write all. Suppose they have given 5 points, write down in this P1 matrix form, and then find out the distance between each point. Euclidean distance you can find out and write down. You have to write down.
Okay, thank you.
Yeah. So in max case, you need to take the maximum value instead of minimum. So I'm not going in detail of this one. It's just everything is same. Only you have to take the maximum value instead of minimum value in complete linkage technique. Next, you have one more average linkage technique. So instead of min max, you need to take average of these two values. So now distance between P1, P3, P1, P5, 3, 11, you have to take average of 3 and 11. Okay. So that is your average linkage technique. So this was agglomerative, 3 different steps, 3 different algorithms in agglomerative. Now we have divisive. Divisive is top down. So here we need to make use of MST, that is minimum spanning tree, and then you need to get your clusters. Okay, I have one problem for this one. So we will see. So again, you have a distance matrix. Okay, or you call it as adjacency matrix. Now you need to draw your minimum spanning tree from this particular matrix. So from this matrix, first write down edge and the cost. So what are all the edges in increasing order? You write down. So if you see, what are all the minimum values? 1, where all we have 1, here, here. Okay, I think need not consider this above 1, only below 1 if you consider, that's enough. Now here if you see, you have, I'll rub it. You have which edge here? A, B. And here which edge you have? C, D. So write down their cost, A, B, C, D. So after 1, take 2. So now you have 2 here, you have here. So which edge is coming here? A, C, and here it is B, C, and one more 2 is here, that is D, A, A, D. So write down those 3 edges and their cost. Similarly, you write down all the edges, okay, for all 1, 2, 3, 4, 5. What are all the edges coming and their cost? Next, draw minimum spanning tree. How do you draw? First, draw a edge A to B. So you have A and then B. So we have drawn one edge. Similarly, then C to D. So take one more. I'll just show up here only. A, B is one edge we have drawn, cost written. Then C, D. This one edge is drawn, cost is written. Then you have AC. AC cost is written. Then you have AD. Here AD will form loop. Hence we should not take this edge. So this forms loop. So that's why I have crossed here. Next BC. BC is also forming loop. Hence cross it here. Next you have AE. From AE you can draw one edge. Again from BE if you are drawing, it forms a loop. So don't consider. Rest all are forming loop. So we are not considering. Now after you have completed your minimum spanning tree, from this minimum spanning tree we will start forming the clusters. Okay. So first what you have to do, whichever edge has the maximum cost, cut that edge. remove that edge. So once you remove that edge, what are the clusters that will be formed? One will be, if I remove this edge, AE, if I cut this is left out one cluster and this is separately left out. So two clusters, E and ABCD. Now in this ABCD, next edge is, highest edge is 2. So cut this. When you cut this, you will be left out with two, you will be left with two more clusters, A, B and C, D. So now you have three clusters, A, B, C, D, E. Again, you can break C, D. Similarly, you can break A, B. Finally, you received your individual elements A, B, C, D, E. So it splits, it creates 5 clusters. So basically, if you remember, I've shown you this diagram, divisive. In divisive, we come top down. Where is that? Yeah. In divisive, we come top down. So from A, B, C, D, E, we finally arrive at your A, B, C, D, E. So in the process, you have got these two clusters. Here you have got these 4 clusters. And then finally you got 2 more clusters here. So basically, I don't understand what the funda is behind this divisive, because at finally he is getting the individual elements only.
I
But
think the difference, which probably a lot of YouTube video don't talk about, is that they can tell you that you limited 3 clusters. So if you limited 3 clusters, then you are left with, if you remove E and if you remove C, then your E is 1, C is 1, and A, B, the rest 3 are 1. So that's probably, if you limit the number of clusters, then you will know which grouping will remain at the end. But I think a lot of YouTube videos take you to the nth level, which then it doesn't make sense, honestly, right?
Yes,
Because then
yes.
you're talking about individual point. But if you limit to 3 clusters, you will see a different outcome.
Yeah, you make sense. Yes. If suppose we have given 3 clusters, then we will stop here. Yeah.
Absolutely. Then only you will see that what is the cluster left.
Yeah. Okay, so this was divisive. Okay, I have not seen any problem in exam based for this one. This one is important, DB scan. We have a problems on this in previous question papers, and this is the important one. So in DB scan clustering algorithm, it is nothing but a direct density reachable clustering algorithm. And here first let's understand some theory. So this says that if you have some point, okay, and two parameters are important, epsilon and minimum points. So to make a cluster, you should satisfy these 2 parameters. That means around that point, what are all the points that are present? If you want to consider under that cluster, the distance of that point should be equal to the should be less than or equal to this epsilon value. So epsilon is nothing but the maximum radius of your neighborhood points, and minimum points is nothing but minimum number of points that are present in those epsilon neighborhood. That means if I take this circle and if I have one point here and if I have some x points here, so which all points I'm going to consider is, if I've given some radius value 2, so which are all the points which are coming within the radius 2? That means here till here till here. Some point, if it is present here, that is not coming in within the radius 2. So we're not going to consider that point. Okay. So that and minimum number of points, it should, like if suppose in question they have given that it should have 4 minimum points, then only you consider that particular point Q, particular point, let's say P here, as the point which can form a cluster, as a core point which can form a cluster. So when we will see the problem, it will be more clear. But before that, we need to understand 3 more points is core point, border point, noise point. So you call your point as a core point if it satisfies epsilon condition and minimum point condition. Okay. That means if it has, if I say minimum point should be 4, if it has 4 points around it, which falls in epsilon radius, then you say that A is capable of forming a core point. Okay. Then we have another thing called border point. Let's say one more point we have B we have. This also falls in the radius of epsilon. That means in this neighborhood only. But it does not have minimum 4 points around it. It has only 2 points around it. Then this particular point cannot be called as core point, but it can be called as border point. Okay, so it is satisfying one condition, that is radius condition, it is satisfying. So that's why we call B point as border point. And then you have another point C, which is a noise point, which does not satisfy epsilon, which does not satisfy. So first condition only it is not satisfying, then you consider that as a noise point. Okay, minimum point will come later. So let's see the problem, then it will be more clear. So this is a problem given, and then we need to, what is the question? Classify. This is the previous exam question problem. So we have to classify all the data points into two types, core point and noise point. And then we have to see which noise point can be converted to border point. In first question, first bit, we have to just classify into core points and noise points. And then second question, we need to see which all noise points can be converted to border point. Okay. First, you plot your values. So P1 is 3, 7. So this is your P1, P7. Then P2 is 4, 6. So this is 0.2, 1, 2, 3. All I have plotted it. Okay. Now epsilon value given is 1.9 and minimum points is 4. Now we'll start with P1. First, what you have to do, you have to draw a adjacency matrix. You have to write a adjacency matrix. This is nothing but your distance between the points. So you write down all the points that you have and find out your Euclidean distance, P1 to P2, P1 to P3, P1 to P4. From all points to each point, like from P1 to all these points, from P2 to all the points, find out the distance and write it down. Next, in your step 2, what you're supposed to do, start with P1. Now we will find in P1's vicinity. Now let's take point P1. In P1's vicinity, which all points are coming? Now you need to satisfy the condition of epsilon, okay, to take the points which are in the neighborhood of P1. So now you should see horizontally also, vertically also. Now horizontally we have nothing here. In vertical, whichever value is less than 1.9. So this is less than 1.9. This is less than 1.9. So which all points are coming in the vicinity of P1, P2 and P10? Write down. Now similarly, do for P2. Now if you go for P2, see horizontally first and then you see vertically. Okay, horizontally you have 1.41, which is less than 1.9, and this distance is from P1. So for P2 we have got 1 point as P1. Now if you see vertically, you have this one P3 and you have P11. So for P2 we have got P1, P3 and P11. So that I have written here. Similarly for P3, P4, P5, P6, P7, P8, P9, P10, P11, P12. All of the points you need to write all the points that are coming in the vicinity. So here when I say vicinity, you need to consider the epsilon radius. Now after you form this table, in this table you need to see which all sets are having 4 points in it, because our second condition is you need to take minimum 4 points. So if you see here, you have 4 minimum points here, you have 4 minimum points here, you have 4 minimum points here. Okay, so P5, P11 and P2 has 4 minimum points within 1.9 centimeter radius. Hence, they have capability to form core point. So next, you need to write down your table where you will. So first bit they have given us that you have to classify all your points in noise and core point, right? So point P1 will be termed as noise point first, because P1 does not have 4 points in its vicinity, and point P2 core point. So all P5, P11 and P2 I have written core points, rest all noise point. Second bit they have asked is check which all you can convert from noise to border point. If you take P1 has
Sorry, just a question, right? So, but the P1 and the other one are meeting the epsilon radius condition, right? So why noise and not border?
Because they don't have 4 points.
but border condition is that it has to only satisfy the epsilon, right?
So that's what initially what I'm trying to say. Initially, all the points other than core we have taken noise. Okay, because in first bit they have asked us to classify bit points two types, core points and noise points. Then second question they have told convert noise point to border points if they directly density reachable from core point. First we have to write down all as noise and core point, and then in second bit you need to see whether that noise point is border point or not border point.
Okay, understood. Yeah. Okay.
Let me. Yeah.
The two parameters are given in the question, right? Epsilon and what? The
Yes,
other...
it's given. Yes, it's given.
Okay.
Yeah. So let me finish this, then it will be clear. So P1, if you see, we have first classified it as noise point, but then we should check. Now in around P1, which all points are coming? P2, P10. Now, if in this P2, P10, is any of the point a core point? Yes, P2 is core point. Hence, you can convert your P1 to border point. Okay, similarly for P3, what are all the points? P2, P4. Here also your P2 is core point, hence you can convert this to border point. But if you see P9, if you see P9, in P9, hello, I was disconnected. Am I audible?
Yes. Yeah, we can hear you.
Yeah. So we have P9, okay. Now if you see P9, what's there with P9? We have P12. But P12 is not a core point, right? So that's why we consider P9 as noise point only. We cannot convert it into border point. If you see your this also, which one is noise point? Yeah, P9 is noise point. So this is here is a noise point, okay? And these are all, and which all have come as core point? P2, P5, P11. So if I go here, this is your P2, P5, and P11. These are all your core points. So if you see it's in one, if you see, if you try to calculate the distance and then you will have 4 points around it, 4 points around it. But around it, you will not have any point, which is core point, okay? So that's how. Is this question clear? This is important.
Anu, just a quick one. How P2 is core? It only has 3 points, right?
No, you should include P2 also. Minimum 4 points in that particular cluster.
Got it. Thanks.
I think it is clear, so I'm moving on. So this is another problem of DB scan. You can try out, okay? Same. So now here points will be given to you, and then you have to. So here they have written, okay? You need to assume Manhattan distance, okay? As a distance measure, epsilon value is given, minimum 0.3 is given. So you can write down the matrix, adjacency matrix, by calculating the Manhattan distance, and then same manner you write down all the, like in the vicinity of A, what are all the points coming, in the vicinity of B, what are all the points. Then you need to see the density, like how many points are here? 3, 3, 3. Here it is only 1, so this is a noise point, and all these are your core points, okay? But then you have to form the clusters. You have to form the clusters. So here this is little different. If you see here, how will you form the clusters now? Okay, you need to take any point. If you take point A, now from point A, which all points are coming in its vicinity? B and C. Does D, E, F, G, H anywhere it visited? No. So you will have one cluster A, B, C. And if you take D point, from D you have E, F. Or you take E point, from E you have D, F. That means D, E and F, they are all coming together. They never occurred in this A, B, C along with A, B, C. Hence D, E, F is one more cluster. So this is how we did the clustering here. Is this point clear? This is the only difference between the first question and the second question. So I'll take silence as positive. I'll move on. BIRCH. Now next is BIRCH clustering algorithm. So this is also important one. So here in this case we use this is a combination of hierarchical clustering and iterative partitioning. That first one K means and DB scan. This is a combination of that. And here we use clustering feature tree. Okay, you need to understand what is this clustering feature tree. Then only we can understand the problem. So to understand clustering feature tree, we draw a clustering feature tree using this clustering feature vector. Okay. Now clustering feature vector has 3 elements in it. N is the number of points, LS is the linear sum of the points, and SS is the square of sum of the points. So let's say some points are given. So this is one set and this is one set. And if I ask you to draw a cluster feature tree, what you have to do? First, you have to form a cluster feature vector. So you need to understand how this cluster feature vectors is formed. How many points we have here? 1, 2, 3, 4, and 5. So 5. Okay. And then linear sum. Linear sum means you need to just add 3 plus 2 plus 4 plus 4 plus 3 and then add here. And square of sum is nothing but square it and then sum it, like 3 square plus 2 square plus 4 square plus. So you need to write down here. Okay. So I've calculated this for CF1 and similarly I calculated this for CF2 also, cluster feature 2. Now if you want to combine, so this is not any problem. Okay, I'm not explaining any problem. I'm just to do a problem, I'm just explaining some basic things that we will make use of. Okay, now if you want to combine CF1 and CF2, how do you combine? You just add all the elements at your XYZ dimensions. Okay, so you have 5 plus 5 and then 16 plus 36. So you need to add, that will be your combination of two cluster features, CF1 and CF2. Now let's see CF tree. CF tree you will draw like this. You will have one root node and then you have a non-leaf node and then you have a leaf node. Okay. And there are two important parameters, branching factor and threshold. Branching factor says maximum number of children. So if branching factor is given as 3 in the problem, then your maximum number of children will be 3. Okay. And threshold is nothing but the maximum diameter of subclusters. So when you do the example, right, that then it will be more clear what is exactly this. This is basically a cluster diameter. Okay. For all the features that are stored at the leaf nodes. These are all the formulas. Centroid, how to find the centroid of the cluster, LS by N. Radius, this is the radius of your cluster, okay, from any point. And this is the diameter formula. So these three formulas are important to do the problem for using BIRCH algorithm. So let's see the problem, then it will be more clear. So now in this we have to cluster all these points and they have given us branching factor threshold value. Okay. First step, step 1, what you have to do, you have to first form a clustering feature vector. This is a step 1. Just I have written some formulas. Okay. So you can make use of these formulas. So N is nothing but number of points, LS is linear sum, SS is square of sum, and this is cluster centroid, this is your cluster diameter. Only these formulas we will make use of in the problem. Now start with 1 point each time, point 2. Now first form a cluster feature for point 2. The cluster feature formula is N, LS, SS. This is the notation, right? So how many points we are taking? Only 1 point. What is a linear sum? Here only 1 point, so 2 only will be there. Square of sum, 2 square, 4. Okay. Now form a CF tree. Take root as a null and then branch it with this. You form a branch and write down this CF value, cluster feature vector here in this. Okay. That's how this tree has been formed. Is it clear till here? Because if this step is not clear, further it will not be clear. Any question till here?
What is root B is equal to 3 means?
Branching factor. That means maximum number of children that this tree will have.
Oh, all right, yeah.
Okay. Next point you have to take point 10. So now here what you have to do, step 2, you need to see, I'm not, I'm going this stepwise, but I'm going a algorithm wise only. I have written these 3 points. Okay. This is the algorithm. So based on this algorithm steps only, the below steps are there, but I don't want to explain this before explaining the problem. Okay. So next algorithm step says that next point, what you need to do, you add it to CF1. So now we have formed in the first step CF1, right? So add 0.10 to CF1. So then you find your new CF and diameter. So now what will be your new CF? Denote it with CF1 dash. So when you are adding your 10 into this, how many points you will have in this now, in this cluster? 2 points. And then add 10 to 2 and 10 square to 4. So next new feature vector, we have got this. Now before adding this feature vector to tree, okay, we need to decide what we should supposed to do. For that, you need to first find out the cluster feature diameter. Cluster feature diameter formula is this. So fill the values in this. 2 into n is number of points 2. ls is ss is 104 minus 2 ls square. ls square means 12 square. So 12 into 12 divided by n into n minus 1. So this is the value we got. Now, threshold value given in the question is 5. Okay, t value is given as 5. Now your diameter 8 is greater than t or less than t? It is greater. So whenever you get your cluster diameter value greater than t, then you have to split your CF1. What is your CF1? This one, right? This one. Now your new CF1 is this one. So you have to split it. You have to split it. CF1 and CF2. So now this becomes your CF1 and this becomes your CF2. So how you split it? Just split it in the sense 1, 2, 4 separate. And then your next point was 10, right? So 1, 10, 100 separate. And the centroid you need to write here. Centroid of this cluster is 2 divided by 1, 2. 10 divided by 1, 10. This formula, ls by n. How many points are there here? 1. So ls value is 2. 2 divided by 1, 2. 10 divided by 1, 10. Next point is point 12. Now, to which cluster feature you supposed to add this point? Here we added because only 1 point was there. We added directly here. But now we have got 2 points in the leaf nodes. Now to which cluster feature you're gonna add? Okay. So what you will do, you'll find out the distance of point 12 from this one and this one. So 12 minus 10 and 12 minus 2. So which one is less? 12 minus 10 is less. Okay. That means this point 12 distance from this feature is less. So we should add point 12 to CF2. So then you calculate new CF2 dash. So here number of points were 1. You added point 12. So number of points will become 2. And then 10 plus 12, 100 plus 12 square. You got your new cluster feature. Again find out the diameter. Now diameter is less than threshold. So when it was greater, we should split. When it is less than, then you should add. So you directly add 0.12 to your CF2. Okay. So in this case, you have added 0.12 to CF2. And then if you see your tree is become like this. In CF2, you have 2 points now. 2 and this value will be 22. 10 plus 12. 100 plus 12 square. 244. And then again recalculate your centroid. 2 divided by 1, 2. 22 divided by 2, 11. Is everybody clear till here?
Anu, if this point instead of 12 it was 6, say it was equidistance from both 2 and 10, then what do we do?
You mean to say this both are equal?
Yeah, in that scenario, what do we do?
That again, I'm not sure.
Sure. Okay, no worries.
Yeah.
I know how the value changed from 21204 in the next one to the root. That value changed from 21204 to 324 248.
Sorry. I was coming here. So see, your parent will change, right? When your child you're adding, this value this value should be sum of this. So you need to keep on writing by adding this one.
Okay, got it. Thank you.
Yeah, sorry, I missed that to tell. So now next point 4. So
can you please repeat the last point? Just
which one?
This one. Just now you mentioned that.
Yeah. What I'm saying is, so here this was our tree like this, right? What did we do? Here we added 0.12 here, right? This point is clear, right?
Yes, clear.
So in your root also, this is your parent. These are your children, right? So parent is always equal to sum of the children values. So when we added here, you have to add in parent also.
Okay.
And when we say B is 3, right? That means now it
now
is
we have 3 points. 2 plus 1, 3 points.
So now we have to pick up another branch, or what is the?
Now another, no. Listen, when we need to take, now next point is 4. Again, same process you do. Now we have see, always you should check the leaf nodes. Now we have 2 leaf nodes here. Now you check the distance of 4 from these 2 leaf nodes, CF1 and CF2. Now distance of 4 from here, 4 minus 2 and 4 minus 11. You should take this centroid value, 4 minus 11, which is less. 4 minus 2 is less. That means the distance from CF1 is less. So you need to add this point to CF1. Okay, we will see when we have to take one more branch. But till now, we are able to use only these 2 branches. Till now, we are able to do with these 2 branches only. So you have added the point 2 here. And then again, you found out the new cluster feature vector, that is 2, 6 and 20. I hope this is clear, right? 4, when you add 4 plus 2, 6, 4 square plus 4, 20, and number of points will increase to 2. So this is your new CF1 dash. And then diameter is less than threshold. So you have to, when it is less, add point. So when you added here one more point, parent also increased by 4. Okay, number of points becomes 4. Again, calculate your centroid, 6 divided by 2. Now here you will understand another branch that has come. Now when we took 0.25, okay, when you see here, this is greater than this, okay, CF2 is more closure. So I added 0.25 to CF2. What is your CF2? 222, 244. So you added into 222, 244, 0.25. Then calculate the diameter, which is coming as negative. So as it is a negative value, you need to add as a separate cluster feature. So 25 we added as a separate cluster feature. I hope this is clear. Similarly,
it is not number of points, it's the only number of branches, huh? Because
yes, it is not number of points. That branching factor is number of children nodes.
Okay.
Next, if you see here, 0.3, next we have taken 0.3 and then we added it to CF1, then 0.30. So all that process is going to be same. I'm not repeating every step. I'll repeat here. Now, if you see 0.20, 20 is more closer to CF3. Okay. So when it is more closer to CF3, you need to consider this CF3 only. And now your D value is less than 5. So sorry, it is greater than. Please make a correction. This I knew that I wrote wrong here. It should be greater than. So 7.707 is greater than. So whenever it is greater than, you have to split it. You have to split your CF3 into 2 different nodes. Okay, one will be whatever with the 0.20 and then leftover value. Okay, and you keep on increasing your parent node. You keep on increasing. Now how many points have come totally? 3, 4, 5 plus 3, 8. So here totally 8. And again, these are the children of this particular node, right? So at any point you should have maximum 3 children. So for this node you have 1, 2, 3. Again for this node you have children. So here only 2 are there. One more can come like this. That is nothing but the branching factor. Okay. And again for point 11 also we will do the same process. So finally the clusters, how you supposed to write? You should see which all points you added to CF1, which all points you added to CF2, which all points you added to CF3 and CF4. So you need to segregate those and those will be your clusters formed.
Anu, I have a question. Can you go back? When you add 20, right? So 20, yeah, 20. So now we got here greater than, right? What happens if it is negative?
Again, you need to, if it is negative, you need to create a separate, that's what, you need to create a separate branch, but here only 3 children you can have, right?
Yeah, that is a question. Right?
Yes, so then, yeah, then I think that should not be allowed, and then there is no specification of such kind of scenario. Basically, we have very less numericals. We have, I mean, these also, we don't have anywhere numericals, first of all, in textbook, and all these edge cases are not covered. Whatever numericals I found out is from somewhere, YouTube or previous papers. So this is the open question.
No. In that case, shall we add another node under root?
Maybe we can clear. I mean, we can concept now. We can write down. Hello, am I audible?
Yes.
Yeah, I'm saying that this is an open question. We don't have any scenario. All the scenarios covered anywhere. All these are edge cases. Maybe we can check with the sir tomorrow in the class. All these cases where you have equal and then where you have negative and then branching factor is 3 only. Then what we should do?
Hey, Anu, how much time more you are going to take?
We have this much more still. How many pages are covered? 26. More 20 pages are there. Yeah, I maybe in next 40 minutes I should be able to finish.
Yes, please continue, Anu.
I think section 1 has a class, Anu, so some of us will drop.
Yeah. That it's up to you. People who can, they can continue. Okay, I will jump into this one now. Cluster validation. So cluster validation is now there are some steps, I mean methods with which you can validate your clusters, whether they're good clusters or not good clusters. Okay. So for cluster validation, you have cluster tendency. Under cluster tendency, you have one concept called Hopkins statistics. Then you have precision, recall, F measure. Okay. Hopkins statistics formula is this. I don't really understand in a very great theory part, but I just understand that your UI is the nearest neighbor distance in the generated data, and WI will be the nearest neighbor distance in the supplied data. It's mentioned like this, but you need to, I'll do one problem for Hopkins statistics also, but this has never come in previous exams. But if you see how you determine whether your cluster is good cluster or not based on this H value. If H is closer to 0, data is highly clustered. If H is closer to 0.5, data is uniformly distributed. Okay. So these two are the values based on which you will define your H value. Now coming to classification based on these precision. Precision is nothing but fraction.
How did you get those values from 0 and 0.5 and all?
This is the definition of this Hopkins statistic.
Okay, fine, thanks.
Now you have precision and recall. Precision is fraction of cluster that consists of objects of a specified class, and recall is extent to which a cluster contain all the objects. See, I don't want to explain this English. Okay, let me go to problem, then it will be more clear. So this is how it is given. Okay, this table is given. So here if you see, I'll first explain what this table is. These are all the classes. Okay. I got disconnected again.
No, your audio was continuous.
No, it's good.
Yeah.
Okay. So you have classes. All these are classes and all these are clusters. Okay. That means in your cluster 1, entertainment, you have 3 objects. Financial, you have 5. Foreign, you have 40. Metro, you have like this. Okay. So for this table, what you do, first you write down total, horizontal and vertical. But you need to understand what this total is. So if you see this total, this is nothing but the total number of objects in cluster 1. And if you see across vertical, this is total number of objects present in entertainment class. Okay, you need to understand this. That's how we will going to calculate precision and recall. Next, they've asked us to find out the precision for cluster 1 and metro class. The meaning of this is, okay, what is the precision of metro class in cluster 1? So how you're going to calculate? How many objects of metro you have in cluster 1? 506. By total number of objects in cluster 1, 677. That will be your precision. And recall is nothing but number of objects of metro in cluster 1 by total number of metro objects that we have across vertical. Just a minute. Just a minute. I think my current is not there. I need to move to a different place. Just a minute. Yeah.
Hey guys.
One question. This is the same precision recall we came across confusion metrics earlier, or is it different?
It's same only, but I mean here it is with respect to these clusters.
Okay.
Yeah. And then you have F value. So F score value is 2 into precision into recall by precision plus recall. I think this formula is same. Okay. So this is your F measure, F score measure of your cluster. So that's how. So now that means your cluster is 0.63. F value got 0.63. So if you find in percentage, 63%. And here F value is 94%. So is this clear? Precision recall calculation?
Oh no, can you explain the F value once more? I missed that part.
Which one? Which one?
F value. How do you calculate?
Here it is, formula is there. 2
So
into precision into recall.
Harmonic, right, between precision and recall.
Sorry?
Harmonic mean of precision and recall.
Yes, it's a harmonic mean of precision and recall. Correct. So here, this question is from previous exam paper. What they have said is they have given some information retrieval system, and they have asked us to find the recall of your IR system, precision and depth score. Now, here, if you see the table, try to understand the table first. In table, we have retrieved documents, not retrieved documents. That means this is your cluster 1, this is your cluster 2. And then you have in cluster 1, how many relevant documents, how many irrelevant. And cluster 2, not retrieved documents, that is how many relevant and how many irrelevant. Now you need to calculate your recall. Recall means based on how many retrieved documents only you will find how many retrieved and how many of them are relevant. That will be the recall of your IR system, right? Recall or precision, whatever it may be. Because if there is no point in considering irrelevant documents, even though they are coming under retrieved. Actually, your IR system, how it is behaving, it is good or bad, that depends on your retrieved documents which are relevant. So here value for that particular factor is 400. So 400 divided by your recall is nothing but across vertical, right? 400 plus 300. And then precision is 400 by 400 plus 240. That means total number of retrieved documents. That is your precision. And then you find out your F score. Again, there is another for, yeah, this is also from previous question paper. This is again same. The table is given with the 3 different clusters and then the classes. I just put the total across vertical and horizontal. And then they are asking us to find the purity of cluster 1 and cluster 2. Okay. How do you find purity? You need to see the for cluster 1. How do you find the purity? For each of these cluster values in the cluster, for each of the classes in the cluster, find the probability of each of the class. The total number of objects are 693. So probability of entertainment is 1 by 693. Probability of finance is 1 by 693. Or you can call probability or precision also. Okay. 0 by 693. So whichever is maximum precision. So that much, whichever value is maximum, that much purity you have in cluster 1. Okay. So for cluster 2, again same way. You need to find out the maximum precision for whichever class is coming. That is the purity of, that much is the purity of your cluster. Okay. Now, what is the entropy? I think we know from previous chapters, entropy formula is this. So they are asking to find the entropy of cluster 1, and they have asked to just write the formula, filled formula. That means you need to fill the formula values. That's it. You need not calculate. So this is the entropy, and you need to just substitute the p values here. That's it. Okay, next, this is also from some previous question paper I took, but this has not been taught in the class in any section. I checked this particular concept. Here they have given us this contingency matrix where they have written all these true, positive, false, negatives for 2 clusters. And using micro averaged and macro averaged method, we need to find F score. So F score formula is 2 RP by R plus P. For that, you need to first find micro averaged precision. This is the formula. And micro averaged recall. This is the formula. And then for macro averaged, this is the formula. Micro average, this is the formula. Okay. I don't know how this formula have come. I just copied from the last year key, question paper key. Okay. But
do you have any intuition on these terms, micro and macro, just in case you have? If you don't have, no issues.
No. I didn't even go through it actually, because
Fine.
I didn't find anywhere. Basically in YouTube it is there, but I didn't go through that. Okay.
Okay, no problem.
So when you have time, you can go through. Yeah. But this is how in the key it is solved. It is very straightforward. Everything depending on this formula. Okay. Yeah. Next is this one. This is that Hopkins statistics. Evaluation of clusters using Hopkins statistics. These are all the topics, you know, they are not taught in a very great extent, but it's always good to just have idea if it appears in the exam. So here also I will just tell you how this problem is solved for Hopkins statistics, but I really don't understand the logic that on the solution that they have used. Okay. I'll just tell you. So they have given this data set and you need to find out the cluster tendency based on Hopkins statistics. That means whether this data set is good to form the cluster or not good to form the cluster. We have seen in Hopkins statistics, if it is 0.5, if the value is of value of H that you're going to calculate, if it is close to 0.5, that means it is uniformly distributed, otherwise not. Okay. Yeah. So first you have to randomly sample.
Is uniformly distributed good for clustering or bad for clustering?
It's not good for cluster. It's not good for clustering.
Okay. So if 0.5 means what actually? What is the implication mentioned?
That is the definition of this Hopkins statistic. So it takes either 0 or either you need to check the value closer to 0 hai, ya fir it is closer to 0.5.
I am asking if uniformly distributed, then it is not good for clustering. So the Hopkins value should be what?
If it is closer to 0.5, whatever value you are getting.
So it's not good for clustering then?
Yes.
Okay.
I'll show you the process how they have done. So they took any 5 points, any randomly. So you can take anything. You should not ask me why I took this. You can take anything, any 5 points they have taken. And then they have tried to find the distance, like from the leftover points. Means from 2 to, now I took 2, 12, 25 and 30. Now leftover are 10, 4, 3 and 11. So what did they do? Distance between 2, 3, whichever is near to 2. Now out of this leftover points, which is near to 2, 3. So they took the distance between 2 and 3. And then for 12, which is the near point, 11. So they took the distance between 12. So whichever is near to this 25 from leftover points. So whichever is near to 30. Okay, not necessarily leftover points, whichever point is near to 30. Now from this set, it is 25. Now whichever point is near to 11, that is 10. So they took the distance for all these 5 points and they sum it. Okay, you got 13. Similarly, they take another 5 points. Okay, again they took some more 5 points. Some points are again repeating, some they took new points. Again they did the same process and find out the distance of the points which is near to those points that they have taken. And then they sum it. Next, they trying to find the Hopkins statistics with the formula. And here Hopkins statistics formula is sigma yi by sigma xi by plus sigma yi. Nothing but the sum, that second sum that you got by first sum plus second sum. And you got value as 0.4, which is closer to 0.5. So data is uniformly distributed as per Hopkins statistics. So it's not much suitable for data clustering. Okay, but what I will suggest is, in order to understand it properly, you should try with different samples. Like here we took this 2, 12. So you need to try out with different by taking 2, 4, 3, 11 or 10, 12, 25, like that. We should do, and we should find out this H value and then see always we are getting value closer to 0.5 or not. Is this clear?
Yes.
Yes. Yes.
Okay, then I'll move on. So this is I think if some of you have done DM assignment of clustering, this will be very clear. So here they have given k value 2, 3, 4, 5, 6, and using elbow test, we need to find out which value is more suitable for k. Like 2, 3, 4, 5, 6. Like how many clusters? I mean, how many clusters are good to form from this data? So first they have asked to use Manhattan distance, and initial centroid they have given 3, 10. So first we start with k equal to 2 and divide this particular data set into 2 clusters. 2 clusters, how will you divide? To 3 near values. Okay. And then you take which are like 4, after 4, 10 is far away, right? So that you take all under another cluster. And then you find some of
Sorry, Anu.
Yeah.
So it said as Manhattan, right? But I think you have taken Euclidean, right?
No, I did not do square root, right?
Manhattan is like absolute value, right? Just q is equals to 1, isn't it?
Manhattan is not sum of square distance.
Okay, yeah, carry on.
Can somebody confirm? Because maybe I might be wrong.
Yeah, Manhattan is a sum of absolute values, like values that we get precisely, not the squares. Euclidean is square root of squares.
Okay, then maybe I made a mistake here. Maybe I thought that between Euclidean and Manhattan only square root is missing. Okay. Okay, then accordingly you make the corrections. Okay. So I did this whatever distance, Manhattan distance you need to do, and then find out the value. So how this distance is done? So for cluster C1, right? Now the 2 centroids are given, 3 and 10. So take this centroid and find the distance for C1, and take this centroid and find the distance with C2. Okay. After you do this and add up all this, you will get the value. Next, using k equal to 3, now again divide this data
I
set.
think, sorry, Anu, you probably may be doing SSC here rather than Manhattan. Because for you to do Elbow method, you have to do a plot between K and SSC, right? So the var K2 here might be SSE, not Manhattan distance. Sum of square errors,
But
right?
if they gave Manhattan distance, then you have to do Manhattan only, right?
Albo method is not with Manhattan, it is
Manhattan. Yeah, I know it is with SSE, but
okay.
my again doubt is if they,
Okay.
this is the problem as it is, I have taken it from somewhere. But if it is not given, let's use SSE. But if it is given Manhattan, then where are we using Manhattan?
Actually,
I
just
thought
to
you
form
use
the
Manhattan to create the cluster.
Manhattan is used to calculate the SSE, right? SSE is like the distance, right? So you can use either Manhattan or Euclidean. So
No, I think
usually,
the difference is that the concept is that when you do a square, it reduces the deviations actually, and it takes away the deviation. That's the purpose of doing the square of it actually. I don't know whether you need to use Manhattan to create the cluster itself, but when you do K and when you draw the plot, it is usually on SSE because that's the way the square help you to reduce the deviation.
correct. So to calculate the SSE, you can use either Manhattan or Euclidean. Square is just one of the values, right? You give the Q value as 2, then it becomes Euclidean. And then if you use as 1, then it is Manhattan. I mean, it's just a way you calculate the SSE. The plot remains the same, K versus SSE.
Okay, then we'll take all the points. Next is K equal to 3. And then here you need to divide your cluster 2 also. Again to another cluster, and because K value is 3 here, and then take is centroid as 25. So centroid means it's the average of this, okay, mean of this. So we have taken new centroid as 25, and then you find the same SSE from here to here, here to here, and here to here, then add up all. Then same you do for K4, to divide again your this cluster, take one more centroid, average of this is the new centroid for C3, and then you find out the SSE. Do for K5, divide your cluster again, K6, and then you plot, okay? For all your K values, you plot your values that you have got for SSE, and wherever you see the sharp, sharp decrease, that is your K optimal value. So for K equal to 2, the value we got was 732. For K equal to 3, it is 57. So here you have large difference, and at K equal to 3, it is going to totally get down. So then for K equal to 3 is the value which we can use for clustering. I hope it's clear.
But just a question on the drop, right? So why not 2 and why 3?
2 is 7. So if you see 2, 732, right? So after 732, where your value is coming very, very low, that is at K equal to 3, right?
Okay, yeah.
7, K
Actually,
equal to 2
because
will be, no, the graph is little wrong. 2 will be somewhere here. Graph will come something like this. So drop is here.
Okay, yeah, then it makes sense. Yeah, because I was like, from the graph, it looks like 2 is more on the elbow side.
This is little wrong.
Yeah, okay, understood. Thank you.
Next is this one. So this Silhouette's coefficient, this is an important concept, but in our sections, they have not taught it in a very great extent. But I heard that it is an important concept. So I've done one problem on this one. Okay. If anybody aware in any section, is it taught? Okay, then we will go. Okay, then we will see the problem. See, this is the distance matrix again, P1, P2, P3. So this is the distance matrix. So in order to calculate Silhouette's coefficient, okay, from each point, how do you do? They have given the two clusters, P1, P2, one cluster, and cluster 2 is P3, P4. Now for P1, you need to find out your A value, B value. So this is the formula, first of all, for Silhouette's coefficient. Now what is B and what is A? A is nothing but the average distance of point P1. Now for P1, first we have to find. So A is average distance of point P1 and all other points in cluster C1. P1 points is coming, P1 is coming in cluster C1, right? So P1 distance from the points which are present in cluster in its own cluster. Okay. Now if you see the distance is average distance is 0.1 only, because you will not consider this point 0 only. So you need to take, so P1 and P2, right? So here you don't consider this. You have to take only this. So it is 0.1. And then B is nothing but average distance of point between P1 and all other points in C2. In C2 we have P3 and P4, right? So the distance is 0.65. P1's distance is 0.65 and 0.55. So take the average. Okay. So we got AB value and then substitute here. Find out the Silhouette's coefficient. Max of AB is 0.6. So this is we got. Now similarly for P2 also find out A and B value. A is nothing but the distance of P2 from the points which are present in its own cluster. What is the cluster of P2? P2's cluster is C1. And in C1, what are all the points we have? P1 and P2. So you need to see the distance of P2 from P1 and P2. You need to do the average. So then that's what we got. Then find out the B, that is P2's distance from P3 and P4. Okay. Then you took the average 0.7 and 0.6 average. And then you got the value for Silhouette's coefficient for point P2. Similarly, find out for point P3, P4. Okay. And then for cluster 1, do the average for Silhouette's coefficient. For cluster 1, which all points P1 and P2. Whatever value you got, do the average for that. For P3 and P4, do the average. That will be for cluster 2. For overall clustering, again do the average of these two. That is your Silhouette's coefficient value final. Okay, I'm moving on. Okay, this is outlier analysis. This is very easy and simple ones. Okay, here outlier analysis is nothing but you need to find the outlier score. Okay, then you have some method called proximity based, and then you have another method called relative density based. Then we have another method called inverse density approach. Okay, all these are all formula based only. So just try to understand how do we calculate the outlier score. So here using proximity based. So this is your distance matrix, and they have asked to use two nearest neighbor method. That means your K value is 2. So outlier score, how do you find is, now for outlier score for each point you will find for point A, for point B, for point C. Okay. How do you find using K nearest neighbor method is from A. Now when they have given K value as 2, from A, which are the two nearest points? So for whichever the distance is less. Okay. Now from A to B distance is 1. A to C distance is 4. A to D distance is 5. So out of these, which are the two lesser values, B and C? That means you take B and C are the nearest point, two nearest neighbor of A, and then find out the outlier score. Outlier score formula is distance of A to B plus distance of A to C divided by K value. So that we got 2.5. Similarly, find out the outlier score of B, C, D, and E. Okay, take two near points from B, two near points from C, and then whichever outlier score is highest, that term is called as outlier. So this is how proximity based formula. Okay, and if K value is given as 3, then you have to take 3 points. Then you have to consider 3 points and then calculate the outlier score. And for whichever outlier score value is more high, that will be termed as your outlier. I hope this is clear. It was very simple.
Yes, yes, please.
Next, we have relative density based outlier detection. So in relative density, you have again same, they will give you K nearest neighbors like 2 if you have to consider. Then for all the objects like uh, A, B, C, D, E, you need to calculate the density. Okay, here we calculated the distance, proximity. Here you calculate the density, and the density formula is this. Okay, this is density based. So distance of A comma B plus distance of A comma C whole inverse. The only difference is they have just taken the inverse. Okay, and then you find out, and whichever score is highest, that is termed as outlier. This is also very straightforward. Next is average relative density. If they have asked you to use average relative density, so this is the formula. Here what they are trying to do, density, if you want to find the average relative density for point A comma 2. Okay, this is again outlier score we are trying to find. So density of A comma 2 by density of B comma 2 by 2. So now density of A comma 2 will be this. Okay, 0.4. And density of B comma 2, density of C comma 2, this is average relative density formula. Here also whichever value will be coming as highest, that is termed as your outlier. And inverse density approach, in inverse density approach, nothing but they have taken distance of A comma B, A comma C inverse. This is same only, inverse density. And if I take this one density. Okay, relative density and inverse density, they both are same, both are same formulas. I don't know why the two different names. No, sorry, 1 minute. In inverse density there is one difference. After calculating the density you have to do 1 by density, sorry. Yeah, that's why we call it as inverse density. Is this all clear? All these methods of calculating outlier score?
Yes, yes.
It's a very straightforward. Next we go to text mining. That's our last one, and that's a very important one. So here this TF IDF concept is important. I see some questions in previous paper. Here basically we are going to do the document text mining. Okay, and we will see which document is having good clustering. Okay, not clustering, we will see which document how the terms are how they are classified based on this TF IDF, based on the terms. So the data will be given. Okay, like in document 1 these are all the terms coming, in document 2 these are all the terms coming. Then first step what you have to do, they have given in the question only, construct a term frequency matrix. This I have taken from previous question paper. Okay, this is how it is given the question. Term frequency matrix you should write down. Term frequency matrix means in document 1 central how many times it is coming, park how many times it is coming, so all the terms. Okay, similarly for D2, D3, D4, D5 you'll write down. Next you need to calculate DF IDF matrix calculation. So you need to form a TF IDF matrix. The TF IDF means term frequency inverse document frequency matrix. Okay, the formula for doing this is TF into IDF. So first you find TF and then IDF. So first understand what is this TF. How do you find TF of D comma T? So for any particular document, for any particular term, TF will be 0 if frequency of that term in that document D is 0. So if I try to find the frequency of TF of Bangalore in document D, it is 0, right? So that's why TF will be 0. In case it is not 0, then the formula is this. Okay. And IDF is nothing but IDF is nothing but log of 1 plus mod D by dt. So dt is nothing but set of document containing the term T, and D is the total number of documents. So if I want to calculate the IDF value for term central, T is a term, particular term. So it will be log 1 plus mod D. Mod D, how many documents we have? 1, 2, 3, 4, 5. Divided by mod T, set of documents. So which all documents contain central? So how many documents contain D1 and D3? So this value will be, DT value will be 2. And then finally you multiply TF and IDF. Now for document 1, calculate TF, IDF for each term. For central, for park, I will just take for one term. And then you can calculate similarly for all other terms. For park, if I take, what is the, in document 1, what is the value of TF? Formula is this, because park has occurred one time in document 1. So substitute here 1 plus log 1 plus log 1, so 1. And IDF value is log of 1 plus total number of documents 5 divided by park has appeared in how many documents? Document 1, document 2. So number of times 2. So that's why divided by 2 and then you get the value. Okay.
Is this log base 2 or log base 10?
It's base 2. Then you find TF dot IDF. Okay. For all the terms you find out. Okay. And then here TF IDF is 0 for other terms because Bangalore, Chennai, all this is not appearing only in document 1. Similarly, for document 2 also we find out TF IDF value, document 3 also, and then document 4 also, then document 5. And then after you finish all the values, again draw your table. It's so not clear. So you write down, okay, all the values, whatever you obtained. So this is your TF IDF matrix. Once you finish this, then you start finding out the similarity of the documents. So in the question, second bit they have asked is, first bit they have asked to construct a term frequency matrix. Next is compute TF IDF matrix. We have done till here. Next is use it to find the most similar document to document 4. So then what you have to do, you have to find the similarity, cosine similarity for each document from document 4, like D1, D4, D2, D4, D3, D4, D4, D5. So cosine similarity formula we know it is V1, V2 by mod V1, V2. So here D1 and D4, these two you should consider. And this is your, so you need to find 0.477 into this, into this, and then substitute in this formula, find out your cosine similarity. Similarly, for D2, D4, you find D3, D4, D4, D5. Now, whichever value is more, if you see this one is high. So D3, D4 are more similar. If you go to the matrix also and go to D3, D4, in D3, if you see, what are all the terms coming? Central in Chennai city, here in Chennai. So if you see D3, D4, you will find these two more similar. If you go to any other, like if I say D1, D4, there is no similarity. Okay. Like that, you can just do some analysis, whether our answer is correct or not. I hope it is clear. This is the previous exam question, so it's important one. Yeah, some 4 more pages are left. Let's finish it. So here also again, they have given some documents. Okay, these are the terms and these are the documents. And they have asked us to find the most similar document pair using cosine similarity. But here they did not ask us to use TF-IDF. They did not ask us to use TF-IDF. So if they don't ask, we can directly use these values only to do the cosine similarity. But here I just did a transpose of this and I have written like this. You have to write it like this. Okay. Otherwise there will be confusion. Write it in this manner. Here in the vertical you write documents and horizontal you write the terms. And then do the cosine similarity. Like do for D1, D2, D1, D3. Then do for D2, D3. And whichever value is coming more, then those two documents are more similar. Okay. Next is this one. This question says that you have 3 documents. Okay. And here you have a query. Now they want us to find out using this query which document will be fetched fast. That means you need to find this query is similar to which document. Okay. Here you write down your term frequency matrix first, D1, D2, D3, and then all the terms and which term is coming, how many number of times in each document. Write down that. Then compute TF IDF. So I'm not going to explain. So for each document, for each term, find out TF IDF value, D1, D2, and then write down your TF IDF matrix. Okay. Now you have to find similarity between your query and your D1. Okay. In your query, they have given only two terms, classification and prediction. So you need to, I mean, in order to do the calculation, the number of terms should be equal, right? Here, you just fill with zeros. Clustering is not there, right? Fill it with 0. Binning is not there. Fill it with 0. In place of classification, it's there. Fill 1. Prediction 1. Regression, big data 0. Okay. In this order only you write this also. Then only it will come correctly. Then you find out the cosine similarity between D1 and Q, D2 and Q, D3 and Q. Now similarity, highest score is for this one. That means similarity score between query and document 1 is highest. Hence document 1 will be retrieved faster as a search query output. Is this question clear?
Yep.
Okay. So
Yes,
this
yes.
is this is the last question. So we'll just see and then finish it off. So here in this question, you have to use inverted index technique for text indexing, and we have to just answer the following question. This is also for previous exam, and they just gave for 1 mark. I think this one. This is given, and you need to just find all the documents associated with term binning. So here we can normally also we can do like which are all the documents where binning is coming, D1, D2, D3, D4, D5. We can write down our answers like this also by seeing that. But in just they have tried to in the key they just try to elaborated it. They form a document table and term table. Okay, just in document table what did they do is they arranged the unique terms in alphabetical order. So they just arranged in alphabetical order, and then from whichever document binning is coming, that is your answer. D1, D2, D3, D4, D5. And second bit they have asked is find all the terms associated with given set of docs D3, D4. For this, they form a term table. That means for each term, which all documents it is appearing. Now, between D3 and D4, which all terms are coming? That is the question. So D3 and D4, where all D3 is coming? Here it is coming. Here it is coming. Here, 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 and here. So in this, which are all the common? Binning is coming in D3, D4, so binning. Clustering is coming in D3, D4, so clustering. Prediction is coming in D3, D4, prediction. And then regression is coming in D4, so regression. Means all the terms that is appearing in D3, D4. We can directly see the answer from here also, but just to elaborate, they did like this. Next, this is the final last. Here, if you see what they're trying to tell is they have given us two documents, dx and dy. And these are all the terms in dx, these are all the terms in dy. And then they have given us some sample data. This is your trained data kind of thing you can think. Okay, this is some data they have given us with which they have trained their model. And for document 1, these are all the terms, and this is classified as clustering. Document 2, these are all the terms, it is classified as augmented reality. Now we have to classify dx and dy based on this data. Okay. For that, what you have to do, you have to find the distance between dx, d1, dx, d2. So your dx document, first let's take dx. You have to find the distance of your dx from all these documents. How did they find the distance is, now in your dx, if you see what are all the terms coming, decision tree, knn, sum. Is it coming anywhere, any of this term in document 1? No. So 1, distance is 1, distance is 1. And again for document 1 also you see, what are all the terms? All these terms, any term is not coming in dx. So for all these terms, you mark at 1, 1 distance, and total distance is 7. Okay. Now for dx and d2 also you find similar way. Okay. And here if you see dx and d5, decision tree is present in d5 also and in dx also. That's why the distance here will be 0. Okay. Rest what are all the terms left out? Kn and sum, and here linear regression. All these three are distinct. So 3 ones are coming here. That's how 3. Now once you find all these, now you have to take 3 nearest neighbor of, because they have asked 3 nearest neighbor you have to consider. Okay. K equal to 3 they have told. So you take the 3 nearest neighbor of dx. Matlab, from dx, what are the 3 different documents whose distance is less? One is d5, and now these are 3 same, right? So take randomly anything. D6, D4 they have taken with class label, classification, AR and classification. Now all these D5, D6, D4, they are classified as classification, AR and classification. Now out of these 3 class labels, which label count is more? Classification. That's why you will classify your document DX under classification. Okay. Now similarly for D5 also you find the distance from D1 to D6. Okay. And here also you take 3 nearest neighbor. Now 3 nearest neighbor in this case will be D1, D1, D5 and D6. Okay. And what are their labels? Clustering, classification, augmented reality. But now all these 3 are distinct. So which one we should take to classify dy? You can take d1, because out of these 3, the minimum distance is with d1 only. That's why you can classify your dy under d1. I mean d1 clustering, d1 classification is clustering. So your dy you classified as clustering and dx as classification. So even if you try to analyze what is the terms present in dx, decision tree, knn and sum, these are the methods of classification, right? And you classified your dy as clustering, and the terms are also related to clustering only. Is this question clear?
Yes. Yes.
Yes, so I am done. So this is all what I have come across. If anybody has any extra topics that they might have covered, please let me also know.
So I know this session was so good. Thanks a lot for taking so much effort to write it down, sharing with us, and then explaining.
Yeah, it's a learning for me also.
Yeah,
I've got
agreed.
yeah.
But it was a very good session. Thank you.
No problem.
Yes, share the recording
Already shared in the WhatsApp group in the morning. No?
Yeah, I already shared it. Please, I'll request don't message me to share anything. I may not be able to take
No,
answer.
I saw it in the Unity group today morning being shared for other groups. Yeah.
No, but the recording, Anu, because there were some corrections.
Yeah. I'll share the recording. Yes. I'll share the recording and the corrections. Yeah, I'll try to make the correction and then reshare the document. Yeah, if possible.
Oh, that's
No,
great.
no issues. We will do it ourselves by seeing the recording. If you don't get the time, but if you get the time and you can do the corrections, then it would be great.
Yeah, okay, I'll check out. Okay, because I wanted to wind up DM today. I'll see if I'm taking some time for DM, then I will do. Okay.
Sure.
Then
Thanks.
only share the recording. We will do it ourselves. Thank you, Anu.
Yeah,
Thank you very much.
Yeah,
Thanks
you can
a lot, Anu.
share it to people who could not attend the recording and document, please. Okay.
Yeah, thank you.
In your, I mean, you can circulate in your sections. Yeah.
And
Thank you.
thanks, Bala, also for organizing this.
Thanks a lot.
Thank you.
Yeah.
Thank you.
Anu, if you can do
Thanks,
for
Anu.
DSAT, that would be great. If you can plan some time.
If somebody can do for me, I'll be thankful.
Is it DSAT?
Yeah. Okay, thanks all.
Thank
Yeah.
you.
Thank you.
Thank you.
Thank you, Anu.
Bye.
Thanks, Anu.
Bye.